Hello dear students, this is your Engineering Mathematics 3 lecture. Today's topic is method of variation of parameters, means BP method. This method is used to find the particular integral. This is the third method to find the particular integral. Already we have discussed two methods, that first one general method and second one shortcut method to find PI, particular integral, means the remaining half solution of LDE. Now the third method is method of variation of parameters. And this method is, we are discussing for one particular case, that is differential equation of order 2 only. When the order of differential equation is 2, then in that case, the auxiliary equation will be of the auxiliary equation will be of a degree 2. If the degree of auxiliary equation is 2, then it has two factors. And its complementary function will contain two arbitrary constants. Means, in that case, the complementary function will be C1y1 plus C2y2. The term with C1 is y1 and the term with C2 is y2, because the differential equation LD, linear differential equation with constant coefficients, this differential equation we are considering of order 2 only here. Its order is 2, so you will get the auxiliary equation of degree 2. The degree of auxiliary equation is 2, so you will get two factors. There are two factors, so your complementary function will contain only two arbitrary constants, and the complementary function will be in this, it will be of type C1y1 plus C2y2. Now the formula to find the PI is by using VP method, means method of variation of parameters is here, uy1 plus vy2. Now what is u and what is v? Here you know what is y1 and y2. Y1 and y2, these are the two functions are from complementary functions. But what about u and v? How to find u and how to find v? For this, to find u and v, the one new term is here d, and it is equal to determinant of first row y1, y2, and second row y1 dash, y2 dash. First row y1, y2, y1, y2, these are the functions from complementary function, and y1 dash is the derivative of y1, y2 dash is the derivative of y2. You solve this determinant, you will get the value of d. Now what is the use of this d? This value is used to find u and v. See, what is the formula to find u and v? U is equal to minus integration x into y2 upon d. Now what is this x? X is the function f of x, which is always there in RHS of LDE, linear differential equation with constant coefficients. The function is always in the RHS side. That term is here x. Y2 is from complementary function. D is this determinant. You solve this determinant, you will get the value of d. You solve this integration with respect to x, you will get the value of u. Now what is v? V is equal to integration x into y1 upon d. X is the function which is present in RHS of LDE given differential equation, that is that x. Y1 is from complementary function. D is the value of this determinant, and you integrate this integration with respect to x, you will get the value of v. After finding the values of u and v, you put in this in the formula of PI. That formula is uy1 plus vy2. Okay. Now, example is here. Solve d square plus 1 into y is equal to cosec x. This is the reduced form of LD, means it is in the form of phi of d into y is equal to f of x. So here the auxiliary equation is d square plus 1 is equal to 0. This is the auxiliary equation. And if we shift this plus 1 here in RHS, it will be d square is equal to minus 1. Square is a negative number, so the factors are here. D is equal to plus minus I. Square is a negative number, so here we introduce I, imaginary number. I square minus, you replace minus 1 by I square, and so the square root of d square is plus minus I, and so there are two roots plus I minus I. Complex roots are there. Then how to write the complementary function for complex roots? We have discussed it in first lecture, how to write the complementary function when the complex roots are there. You know, complex roots always occur in pairs. So here the real part of complex number is 0, imaginary part is 1. The coefficient of I is 1, so its imaginary part is 1. So the complementary function is here e raised to 0x, e raised to 0x, alpha is 0, real part is 0, so e raised to 0x in bracket c1 cos x plus c2 sin x. Now e raised to 0x is 1. So no need to write the term e raised to 0x, and so complementary function is here only c1 cos x plus c2 sin x. So complementary function is here c1 cos x. Now the complementary function is here c1 y1 plus c2 y2. The complementary function is actually c1 cos x plus c2 sin x. But we can write this complementary function as c1 y1 plus c2 y2, where y1 is the term with c1. The term with c1 is cos x, so y1 is equal to cos x, and the term with c2 is sin x, so y2 is equal to sin x. Now the formula to find the pi is here uy1 plus vy2, because we are going to solve this example by using VP method. So the formula to find the pi by using VP method is here uy1 plus vy2. Now you know the values of y1 and y2. These are the values from complementary function. But what about u and v? To find u and v, you first find d. Now what is d? D is the determinant y1, y2, y1 dash, y2 dash is here. These are the derivatives here. So the formula to find the d is here y1, y2, y1 dash, y2 dash. Y1 dash is the derivative of y1 and y2 dash is the derivative of y2. These are the corrections here. Second row are the derivative terms of y1, y2. So y1 is here cos x. Y1, y2 are from complementary function. See here. Y1 is cos x and y2 is sin x. So in first row you write cos x and sin x. Now derivative of cos x is minus sin x. So you write down minus sin x in second row. And then derivative of sin x is cos x. So you solve this determinant. If we solve this determinant, cos x multiplication cos x into cos x, cos square x minus sin for second term. But sin x into minus sin x is minus sin square x. So minus minus plus. So cos square x plus sin square x is equal to 1. So the value of d is 1. And so u is equal to, the formula to find u is equal to minus of integration y to x upon d dx. Now what is y2? Y2 is here sin x. So in you put the value of put the value of y2. Y2 is sin x. And what is the function here? Function is here cosec x. You write down. See, function is here cosec x. In RHS, the function is here cosec x. This is the value of x. Capital X is this RHS function, and this value is cosec x here. So you put cosec x, y1 x is cos x is cosec x, and the determinant value is, sorry, this is our formula of u minus sign as it is, integration y2 is here sin x, x is cosec x, and the value of d is 1. So sin x into cosec x. Cosec x means 1 upon sin x. So sin x get cancelled. Integration of dx is x. So the value of u is minus x. Now how to find v? V is equal to integration y1 x upon d dx. Now what is y1? Y1 is cos x is cosec x, and the value of d is 1. You just put these values here, simplify it. Cosec x means 1 upon sin x. So cos x upon sin x is cot x. And so integration of cot function is cot x is log of sin x. So the value of v is log of sin x. So what is pi? Pi is equal to u y1 plus v y2. U y1, u is minus x, y1 is cos x plus v. V is here sin x, sorry, v is here log of sin x into u y1 plus v y2. Y2 is here sin x. And so the general solution is y is equal to CA plus PI. Write down the general solution. Now the second example is here. Solve d square plus 1 into y is equal to 1 upon 1 plus sin x. This is the LD in the form of pi of d into y is equal to f of x. Now here d square plus 1 is equal to 0 is an auxiliary equation. Again the factors are here. D square is equal to minus 1, square is a negative number, so introduce here the imaginary number I square. So the factors are here, d is equal to plus minus I. So complex roots are there. So similar to first example, the complex complementary function is here c1 cos x plus c2 sin x, because the real part of complex number is 0 and imaginary part is here 1. So here alpha is absent, so the complementary function is only c1 cos x plus c2 sin x. So we can write this complementary function in the form of c1 y1 plus c2 y2, where y1 is equal to cos x and y2 is equal to sin x. And the term with c1 is y1 and the term with c2 is y2. And again the formula to find pi is here u y1 plus v y2. And now to find u and v, you first find d. You know what is d? Is the determinant y1 y2, second row y1 dash y2 dash. So put here the values of y1 y2. Y1 is here cos x and y2 is here sin x. Y1 dash is here. Y1 dash is here derivative of y1 minus sin x, and y2 is sin x. So derivative of sin x is here cos x. Solve this determinant. If we solve this determinant, we have cos square x plus sin square x is equal to 1. So the value of d is 1. Now find u and v. To find u, the formula is minus integration y2x upon d into dx. Now y2 is here sin x, so put y2 is equal to sin x. Now what is x? X is the function in RHS in the given LD. The given LD is this one, linear differential equation is this one. In RHS side, the function is 1 upon 1 plus sin x. So your x, capital X in the formula is 1 upon 1 plus sin x into dx. Now how to solve this integration? Sin x upon 1 plus sin x. So multiply and divide the term by 1 minus sin x here, so that you will get the term minus integration sin x as it is 1 minus sin x upon 1 plus sin x into 1 minus sin x. So in numerator, you solve the bracket term for sin x. So it is sin x minus sin square x. In denominator, the term is 1 plus sin x into 1 minus sin x, means it is in the form of a plus b, a minus b. And so the reduction is a square minus b square. So here the reduction is 1 minus sin square x, or 1 plus sin x into 1 minus sin x. 1 minus sin square is sin square x is cos square x, because from this cos square x plus sin square x is 1. So the value of, if we shift this sin square x here, if we shift this sin square x is here, then 1 minus sin square x is cos square x. So you replace 1 minus sin square x by cos square x. And so the term is here sin x minus sin square x upon cos square x. Now separate these two terms. There are two terms, separate these two terms, minus sign is also there. So carry that minus sign, integration minus sin x upon cos square x dx. This minus minus plus integration sin square x upon cos square x into dx. So minus sign common, integration sin x upon cos square x. Sin x upon cos x is tan x. One cos function is there in denominator because here it is the square of cos function. So 1 upon cos means sec. So the simplification of this sin x upon cos square x is sec x into tan x, minus sign as it is, plus sin square x upon cos square x is tan square x dx. And the integration of sec x tan x is sec x. So minus sign as it is. So integration of sec x tan x is sec x. So the answer is it is equal to minus sec x plus integration of tan square x. Integration of tan square x, you first use the formula tan square x is equal to sec square x minus 1. So again separate these two terms and integrate. So it is equal to minus sec x plus integration of sec square x is tan x, and minus 1 integration is minus x. So it is u is equal to minus sec x plus tan x minus x. So this is the value of u. Now what is v? V is equal to, formula to find v is integration y1 x upon d dx. Now the value of y1 is cos x. The value of x, RHS function, is 1 upon 1 plus sin x. D is 1. So 1 as it is, integration with respect to x. Now how to solve this integration? The denominator term is 1 plus sin x, and the derivative of denominator term, derivative of 1 is 0, derivative of sine function is cos x. So derivative of denominator term is adjusted in numerator. So integration of the term cos x upon 1 plus sin x is equal to log of 1 plus sin x. This is the integration. And then the pi is, the value of v is here log of 1 plus sin x, and so pi is equal to uy1, u into y1. U is here minus sec x plus tan x minus x, u y1. Y1, what is y1? Y1 is here cos x. So multiply the term of u by cos x. If we multiply this u by cos x into sec x will get cancelled. Here it will be minus 1 only, plus tan x into cos x will be only sin x, minus x into cos x. So this is first term, u y1 plus v by 2. V is sin x, sorry, v is log of 1 plus sin x into v by 2. Y2 is sin x. So this is your pi, and then the general solution is y is equal to cf plus pi, complementary function for particular integral. This is second example. And next example, you take it as a homework. Solve d square plus 3d plus 2 into y is equal to e into e to the power x. So you take it as a homework. You try to solve this example. And so this is the VP method. Discuss the VP method or method of variation of parameters to find a particular integral, and it is the special case of second order differential equation only. Discuss for only second order linear differential equation with constant coefficient. So here all the methods to find a particular integral is over. Discuss three methods: general method, shortcut method, and third is VP method, method of variation of parameters to find the particular integral, means to find the remaining half solution of LD, linear differential equation with constant coefficients. So here all the methods are over to find the PI. Now in next lecture we are going to discuss the equations which are reducible, differential equations reducible to LD, means the differential equations which are not LD, but we can reduce that differential equations to LD, linear differential equation with constant coefficients. And after reducing to LD, we can solve the examples. So this session is over here. Thank you.